Welcome back to my code review. For this section, I will be conducting a code review for another one of my previous projects. The artifact I have selected falls under the category of data structures and algorithms. The theme for this project is a popular treasure hunt game in which the player needs to find the treasure before the pirate does. While I did not develop the entire game, I will write the part of the game that represents the intelligent agent, which is the pirate in this case. The pirate will try to find the optimal path to the treasure using deep Q learning. I've been provided with 2 Python classes and this notebook to help me with this assignment. The first class, treasuremaze.py, represents the environment, which includes a maze object defined as a matrix. The second class, gameexperience.py, stores the episodes, that is, all the states that come in between the initial state and the terminal state. This is later used by the agent for learning by experience called exploration. This notebook shows how to play a game. My task was to complete the deep Q learning implementation, for which a skeleton implementation has already been provided. So for this is my second artifact, the Pirate AI project, a deep Q learning for treasure hunt game. And I'm going to describe its functionality, analyze the code using the provided checklist, and discuss my enhancement plan. The provided code implements a reinforcement learning agent using deep Q learning for a treasure hunt game. The key functionality includes a grid-based navigation. The agent explores the environment while learning optimal paths to reach the treasure. Q learning implementation, using a Q table to store rewards and update values dynamically. It also uses reinforcement learning training loop. The agent interacts with the environment, receives rewards, and updates its policy accordingly. Lastly, obstacle handling. The game includes obstacles that the agent must learn to avoid. Now moving on to the checklist. For structure, the structure is mostly clear with well-defined sections for initializing the game environment, training the model, and managing the experience replay. However, there are some areas where code could be refactored. The QTrain function is quite large and could be broken down into smaller, more manageable functions, like separating the model training loop from the QLearning environment management. The if len valid action, which is down here, the if len valid action is equal to 0 break condition inside the QTrain method indicates a potential issue. It terminates the episode prematurely if there are no valid actions, but there might be scenarios where this isn't expected behavior. I'll consider adding a more robust error handling or conditions. Moving on to documentation. The comments. The code has minimal inline documentation, particularly inside the QTrain function. Adding comments would improve maintainability, especially in complex sections such as the exploration versus exploitation decision-making and neural network training steps. For function docstrings, there are no function docstrings in most methods. Each function should have a docstring explaining its purpose, input parameters, and output. Next, variables. Most variable names are clear, such as epsilon model reward, but some could be further clarified. Environment state could be renamed to state for better readability. And agent underscore cell is capitalized, which is unusual for a variable. It would be better named lowercase agent cell to conform to standard Python conventions. It appears that n underscore episodes is incremented but never used beyond the loop. If it's not necessary for the logic, it can be removed. Next, for arithmetic operations, the code avoids comparing floating point numbers directly, which is good practice. However, I should ensure that any arithmetic operations involving floating point numbers, like the loss calculation and learning rate decay, are handled carefully to avoid rounding issues, especially when the values get very small. Next, loops and branches. The loop structure in the QTraining function is logically correct, but could be simplified for clarity. For example, the decision to either explore or exploit could be refactored into its own method to make the code more modular. The conditional branches for checking if the game is won or lost. Found in if game underscore status is win are good, but could be simplified by returning early from the function if the condition is met, rather than using a game over flag. Lastly, for defensive programming, the code does a reasonable job of handling edge cases like no valid actions, but there is room for improvement in testing inputs, such as ensuring that all input values, opt parameters, are validated before being used, adding checks for boundary conditions in array manipulations, especially when interacting with QMaze and other objects, and error handling for failed model training or invalid state transitions. Areas for improvement and enhancement. Code modularity, breaking down the QTrain function into smaller functions, explore or exploit, train model, run episode for better readability and maintainability. Error handling, add checks for invalid actions and edge cases where the game might break, such as when the agent cannot move or when invalid states are encountered. Comments and documentation, add more inline comments and function docstrings to explain the purpose and behavior of each part of the code. This will help others and my future self understand the logic more easily. Variable naming, renaming some variables to follow Python conventions and improve clarity. Performance optimizations, review the code for any redundant calculations like repeatedly calculating epsilon, and optimize where possible to improve runtime efficiency. Testing and validation, ensure that unit tests are written for the game logic. For example, testing that the agent can successfully navigate the maze and complete the game. My enhancement plan, to improve the existing code, I plan to refactor the QTrain function by breaking it down into smaller, well-defined functions, making it easier to maintain and extend. Add more thorough error handling, especially around actions and invalid states, to ensure that the game runs smoothly, even in edge cases. Optimize performance by simplifying redundant code and ensuring that calculations are efficient, such as reevaluating when and how to decay epsilon. Improve comments and documentation to make the code easier to follow and understand. Demonstrate skills in modularity and error handling and code optimization through these changes. For course outcomes supported by these enhancements, design and engineering, refactoring the code and optimizing performance aligns with software design principles and good engineering practices. Improving the Q-learning algorithm's efficiency and modularity showcases my understanding of algorithms, and data structures. By ensuring proper error handling and testing, I will demonstrate a focus on creating reliable and robust software. Lastly, for course outcomes, demonstrating innovative techniques in reinforcement learning. The project will incorporate advanced reinforcement learning strategies to optimize agent behavior. The proposed enhancements will improve the efficiency of the agent's learning algorithm, increase the complexity of the decision-making process, and optimize memory usage. By focusing on algorithm optimization and data structure improvements, this will showcase my skills in applying algorithmic principles to real-world problem solving and demonstrate innovative techniques in reinforcement learning.